So I'd like to just do a summary of electromagnetism up to now. You might feel like we've done a lot of different things, but really, it can be summarized in just a couple of things, right? So we started in electricity and magnetism, or electromagnetism, with the electric field or electric force of a point charge. We said that any distribution of charges can be added up, can be made up of a sum of point charges. And then we said for any distribution of charge that the electric force on a test charge Q or a point charge Q is equal to Q times E. And by the way, the first thing we started with was Coulomb's law. The next equation wasn't given a name till we added it to Lorentz Force Law. Then we said there's another way of looking at electric fields, and that is through Gauss's law. E dot dA, which is a surface integral, is equal to, which is flux, electric flux, is Q enclosed over epsilon 0. And then I do bring up something that you need to remember, because this is going to be relevant soon, is that we derived from work energy theorem that the potential difference between 2 points in space is minus E dot dl. That's called a line integral as opposed to a surface integral. Surface integral is an area integral, line integral is along a line. But anyway, that's going to be relevant later, but that's not given a name yet. And then we moved over to magnetism, and we said for a point charge or a current element, and you've got to recognize this this IDL is like a QV, right? It's a little piece of current moving through space, which is the same as a charge moving through space. So, and that can be seen better in this equation here. But let me just go. Biot-Savart Law is how we calculate magnetic fields from point charges, moving point charges. And then we also said that there's a magnetic force due to magnetic fields, and we did this backwards because we did this before we did Biot-Savart, but there's a magnetic force due to charges moving in magnetic fields, which is QV cross B, which is also IL cross B. Have to recognize again that moving charges are equal to currents moving, right? They're the same thing. And then we put the two force laws together to be the Lorentz Force Law. The Lorentz Force Law. So we now no longer need this or this separately, and then we give them a name. So I'm looking at the named laws. We've got the Lorentz Force Law, the Biot-Savart Law. The Lorentz Force Law is the force on a moving the Lorentz Force Law is the force on a charged particle in an electromagnetic field, whether it's moving or not. The Biot-Savart Law is how we calculate magnetic fields from moving charges. The Gauss's law is how we calculate electric fields from charges. And Coulomb's law is also. So Coulomb's law is really just a repeat of Gauss's law. But it's for the amount of calculus we know right now, sometimes we got to use Coulomb's law instead of Gauss's law. But Gauss's law is really a better form of Coulomb's law if we can use it. So that's where we are right now. I want to make sure you remember that, because that is everything. Everything we have done is encompassed in this. Everything is a derivation directly from these things. The things that we did not derive are this. Yeah, so the things that we did not derive are the things with the arrows. And so those were taken as given, and then everything else we've done is derived. Including the potential difference line integral, but I'm bringing that up because we're gonna do more with that in a little bit. That's gonna be important. Okay, so that's just a summary of where we are right now, and we are gonna in the next couple classes we're gonna finish up electricity and magnetism and fill out this list of equations until we have a complete list of equations that describes all of electricity and magnetism. And we're almost there. We've got just two more, or one more, and the modification of the delta V equation. And we're done, and we've got all of Maxwell's equations. And I'll just give you a little heads up. Did I just say it? That's called Maxwell's equations. All the equations that describe all of electricity and magnetism. It's super important. Like, there's only a couple of them that describes everything electricity and magnetism, and it's called Maxwell's equations when we put them together. And it's pretty famous, Maxwell's equations, that there really are just sort of four equations plus the Lorentz Force Law. It's not one of Maxwell's equations, and I'll tell you that later again. But Maxwell's equations describe all electricity and magnetism in a pretty succinct form. Not all, and just make sure we understand that these are not all Maxwell's equations yet. we'll get there. But that's where we're going. We're going to add in 2 more equations, 2 more things that you need to know about magnetism, and we will have encompassed all of electricity and magnetism. We will have described the world. We will have described how everything's been invented, or the background to everything that's been invented that is electrical, and everything that's been discovered, etc., in 4 simple equations. Maybe not simple, sorry. 4 succinct equations.